So, friends, good morning. Welcome to this lecture series of geomorphology. So, today we will discuss about a new topic that is called tectonics geomorphology. What does it mean? What is tectonics geomorphology? Here two things to be understood here. The geomorphological processes, either it is fluvial process or glacial process, aeolian process or marine coastal processes, somehow they are influenced by tectonics, faulting, folding, thrusting. So, these tectonic processes mostly they influence the fluvial geomorphologic processes. The river terraces are formed, the flood plains are widened, river get deepens, this sedimentation production is more and sink area will be more. So, that means by anyway these tectonic processes they are influencing the geomorphic processes. Mainly the tectonically active regions, for example, if you take this in Indian context, if you are talking, if you take in terms of Himalayan terrain, it is tectonically more active. That is why these geomorphic processes they frequently modify their position, the geomorphic processes they frequently modify these land surfaces, this sedimentation process, the river morphology like that. But if you go to this peninsular system, it is tectonically more stable, it is hardly the tectonic process it influence the geomorphic process. But one thing has to be understood here, one is the process, another is the response. For example, a fault which was formed million years scale, million years time scale back. So, suppose for example of 1 meter throw, that 1 meter throw it is if it is in a tectonically active region like this Ganga plain, like this Himalayas, within and where this fluvial process is very intense, within a year or within a tens of years it will peneplane this, that means this fault scarp will degrade and finally there will be a plain land. But the same 1 meter throw fault, if it is occurring in peninsular India in the hard rock terrain, it will be difficult for the geomorphic process to modify it, to peneplane it within that time scale. So, that means the response of the geomorphic system to that 1 meter throw of a fault is different in time scale is concerned. So, that means process and response they are two different things and is to be understood here. So, in this class we will talk about this tectonics geomorphology, how the tectonics is influencing the geomorphic processes and how the geomorphic processes are readily modified by the tectonic processes we will discuss here. So, the core of this tectonics geomorphology is based on the competition between tectonic process that tend to build the topography and the surface processes that tend to tear them down. So, here the tussle between the tectonics and the geomorphic process. Tectonic process is always want to make this topography, either it is positive topography or this negative topography, and the geomorphic process always try to make the surface of this earth peneplane. If you know the Davis geomorphic cycle, here it can be applied that this tectonic process is one within a sudden, within a small time scale, some time limit, a upliftment will be there and that uplifted part will be readily modified by the geomorphic process gradually and finally it comes to the monadnock stage. It will take long time to respond the geomorphic process to this tectonic activity. So, that means it is the tussle between this tectonic process and the geomorphic process to modify the earth surface readily. So, if you see this figure given below, in this figure if you see this is the thrust and here this is a blind thrust, that means it is just buried or it is developing and not reached up to the surface. Similarly, another thrust which is south of this one, if it is north, so it is south of this one, again it is somewhat more depth as compared to this one. but with time if you see here, this thrust has reached up to this and it is here it is influencing sediment. Similarly, this thrust had reached up to this and has influenced the surface sediment, and here new thrust are coming up. So, in this case if you see these surface geomorphic processes, here a river is flowing, this is the Piedmont of area Piedmont of this zone. Now, you see the surface geomorphology, it is affecting the fluvial process, the Piedmont development, the sediment migration, this like other the groundwater movement, like this other processes also they are influencing. So, that I want to say the tectonic process with time they influence the geomorphic surface very effectively. The core of tectonics geomorphology is based on the competition between the tectonic process that tend to build the topography and the surfacial process that tend to tear them down. So, the resultant is in front of us. So, within a million years time scale or the time window, if you take the thousands of year of time window, within that time window whatever the tectonic process is there, whatever the geomorphic processes is there. So, combinedly they modify this earth surface and finally, within that time window we are looking the resultant modified version of this earth surface. So, as a consequence these unquantified models are often viewed skeptically and treated them speculative. What are these unquantified models? You see there are many models, there are many models has been prepared for this by looking this interaction of the tectonic process and geomorphic process. But with all these models they are lack of, or many of these models they are lack of time constraints. So, there is no time, time means rate, what rate the process is working, what rate this sediment is eroding, at what rate the deposition is going on, what rate a river is shifting its course. So, at what rate the river valley is widening or deepening. So, that means this rate, when we say the rate, that means it is a quantified model, because we can predict from this quantified model, we can predict. If you remember our earlier classes when I talking about the geomorphological models, in these models we could discuss that there is a time frame which is required. Time frame, the time constraint should be required, because we want to predict the future. So, if this rate of river erosion is going on, so valley will widen in these years, or this river there will be flooded, this valley will be flooded within this much area and this within the time frame. So, that until unless this time constraint is given, until unless this time bracket is given, so these models, whatever the models we prepare, they are the unquantified models. So, in geological past, in this literature there are models available, but most of these models are unquantified model, because this time scale is not given. So, to predict these geomorphic features which can work with futures. So, to predict that we need time constraints, that will be a quantified model. So, if you see here this young stage and this is mature stage, this is old stage of the, and this is the block diagram given here. At what rate, if we can calculate here, this is the rate of river erosion, this is the rate of valley degradation. So, that means we can predict with this time scale we will get a valley of this much size, we will get a valley of this much shape and size. So, that prediction is a quantified model. So, now techniques for determining the age of landscape features are available for assessing the mechanism of rate of geomorphic processes, and the defined rate of crustal movement have been helped revitalize the field of tectonics geomorphology. We have many dating techniques available, very precise dating techniques available, but some dating techniques they are very useful for this geomorphological use, but some of them are not. For example, if you are taking some Precambrian rocks to date, it will some million years plus minus some million years, that means million year scale is the error. But if we take this quaternaries, if some 1000 years, some hundreds of years is the error. So, that means in geomorphic process, this geomorphic process within hundreds of years, within thousands of years. So, that means within that error limit we are bracketing this geomorphic process. So, that means what type of dating techniques we will use in geomorphological modeling. So, that is also important. We can now quantify how rapidly the rivers and glaciers are incising into bedrock and the rate at which the landscapes are stripping at mountain slopes. So, those quantification it essential for predicting the future and preparing a quantified geomorphic model. So, if you see here this digital elevation model around the Himalaya, you will see this is one thrust which is south of this Himalayan frontal thrust and it is in the Himalayan Piedmont. So, now you see within that one thrust here if you see we are getting this red one, we are getting some of this erosional topography, but as compared to this topography is near about smooth. So, that means it says even if we have one thrust, even if we have one fault, but the whole fault or the whole thrust segment it is not active throughout its length in a particular geological time or in a particular time. So, that means to predict this we need different types of models, different types of constraints and dependable parameters, is not it. So, that is why this modeling in geomorphology and it is a time specific modeling and time quantified modeling is important. Clearly, the merger of such data sets can underpin a new understanding of the balance between the rate of at which this crustal material is being added at the given site and the rate at which this material is eroded away represents a major component of modern tectonic geomorphology. So, if you remember when we were talking about this hill slopes types, three types of hill slopes are there, waxing slope, waning slope and straight slope. So, this material added if it is more than the material removed, so that will be a waxing or convex slope, is not it. Similarly, this tectonics geomorphology it deals with the balancing budget between the material is added by the tectonic process and removal by this geomorphic process and what type of topography it is going to built here in a specific site. This is a fundamental understanding of tectonics geomorphology. So, in this way the tectonics geomorphology is a blend of few disparate topics of like seismology, quaternary climate change, like structure or rock structure, there is geodesy, geomorphology and finally the geochronology. So, geochronology it is important here because through the tectonics geomorphology we want to understand the tectonic process and the geomorphic process and we want to predict the future. Until unless geochronology is divided, that means the rate is not known to us. So, that means prediction is impossible. So, that is why geochronology it is very important in terms of quaternary geomorphology and what type of geochronology we will choose that depends upon what type of time scale we want to predict. So, that is why seismology it is important because seismic processes they influence or the mostly the tectonic processes are seismic processes they influence the morphology. Then quaternary climate change that is also an important parameters in tectonic geomorphology, quaternary climate change. So, climate change in geological past even if in quaternary we have experienced many times the climate change, the warm and humid and glacial, that means glacial and interglacial time. In glacial times most of this water they were freezed and the sea level was much below this present sea level and there will be no more much sediment was available, either the sediment was due to the glacial actions, but in interglacial time there will be fluvial systems, they are very active and finally we are getting a system which is much more wider geomorphic variability as compared to this glacial systems. Similarly, these rock structures that also define what type of geomorphic features will be, either it is faulted terrain, it is a jointed terrain, it is a folded terrain, it is a dome, basins are there. So, by looking at geomorphic feature we can predict what type of structure also lies beneath to certain extent. Then geodesy it is the geophysics and how this gravity is working, how this gravity is has responsible for this hill slope development, what the material movement, the mass wasting. Then geomorphology, geomorphology means this processes, that fluvial process, glacial process, aeolian process. So, all these processes that work together. So, this is geomorphology, and finally, the geochronology. So, measurement of this amount and rate of erosional losses. Here measurement amount, not only amount is important, it is the rate also important, at what rate the erosion is going on. So, amount and rate of erosional losses from an area, and to define change in height of the surface, that same area through time lies at the heart of many tectonic geomorphology. So, to what at particular site is chosen, in that particular site how much amount of material is added with time and how much material is being removed with time, that is measured, and this measurement has been shown in different ways with the help of this climate, with the help of seismicity, with the time, geodesy, structure, geomorphology, all those things they contribute together in terms of tectonic geomorphology. So, what information from this earth surface improves our understanding about the interaction between the tectonics and geomorphological processes, and how do we interpret preserved geomorphic features in order to reveal the rates and patterns of tectonic deformations in the past. So, these are the two questions has to be answered in tectonic geomorphology. One is by looking the past topography, the past geomorphological features, we can unravel the what rate it was acting, and the present day what is happening in front of us, from which the rate of activities, the rate of geomorphic activities we can retrieve. So, that there has to be compared whether this past activity and the present activity they are going on at the same rate, or there is a change of the rate of formation or denotation of these processes. That is one branch or one solution to this tectonic geomorphological studies. Climate cycles are often the drivers that generate the geomorphic markers in the form of moraines, in the form of marine and fluvial terraces, and that are so important in the field of tectonic geomorphology. These are the geomorphic markers here. One this is geomorphic marker. What are the geomorphic markers? Geomorphic marker, they are special types of geomorphic features that are specific to a particular type of tectonic activities or particular type of geomorphic activities. For example, if you see here in this figure it is given here the rivers, one river is here, second river, the third, fourth, and whatever these rivers. If you see this line, along this line some of these points are there, these rivers are converging, some of these rivers they are getting high sinuosity, some of the river they are diverting or it is offset. Similarly, here along this line there river convergence is there, the river offset is there, this is river sinuosity is there, similarly offset is there. So, these are interpreted as fault. So, these faults, they are surface faults, they are influencing the geomorphic features, or they are influencing the tectonic or the tectonic process, they are influencing the geomorphic features. So, these are the geomorphic markers, the river offset, the river convergence, the increase of sinuosity, generation of new channels. So, these are the geomorphic markers. So, similarly, in marine terraces, in tectonic terraces, there are different geomorphic features, geomorphic markers are available. So, due to this geomorphic marker, by help of this geomorphic marker, we can say what type of tectonic process is going on, either there is a faulting going on, there is a terrace development is going on, or there is a subsidence, there is an upliftment, like that. So, these geomorphic markers plays important role to define what type of tectonic features are going to happen, or what type of tectonic features are there inside the sedimentary cover or within that rocks. So, the often used term tectonic process is a grab bag expression that encompasses all type of deformation, including the motion of tectonic plates, slip of individual faults, ductile deformation and isostatic processes. So, once we say it is a tectonic process, that means all these type of activities associated with the deformation, that is associated here. So, now the question arises, have these rates been steady or over time? So, this deformation, suppose in slip a fault is active, but its activity is same throughout the geological past, it is same throughout the geological time. Or do the individual faults rupture at a regular interval and produce earthquakes of similar magnitude throughout the time? Or do groups of faults accelerate synchronously at the expense of other faults? So, these are these questions, if what type of tectonic terrain we are dealing with. So, this type of accordingly will generate this number of questions, n number of questions accordingly. So, what type of tectonic features we are dealing with, what type of tectonic geomorphic features we are dealing with, in which type of terrain we are dealing with. So, accordingly there are number of questions to be asked, and those questions will be answered through the geomorphologic process, geomorphic rate of processes and geomorphological features, and that is an integral part, or it will be integrated together to define, to explain the tectonic geomorphological processes in that particular region. How Another question is, how large are these earthquake ruptures that accommodate the stress that built by this incessant deformation of this crust. So, here an Indian example or Indian case studies, there very recent there is a earthquake on 2nd June 2017 at 4.7 magnitude, this is called Mahendragarh Dehradun fault, focused around 10 kilometer depth, leaves no evidence of surface rupture. Here you see, this is Delhi Haridwar ridge and this is the eastern part of this Delhi Haridwar ridge, there is Mahendragarh Dehradun fault. It in 2017 2nd June there was earthquake 4.7 MB magnitude. But near about this area, near about this epicenter, there was no surface rupture available. So, that does not mean the geomorphic process will not working there, or geomorphic process will not be influenced there. Now, you see what is happening inside. Though there was no question of surface rupture, but there was subsurface evidences, there are faults, there are fractures within that. So, this ground penetrating radar profile, this is a ground penetrating radar profile, it says that though there is no surface rupture available, but surface faulting available, but the subsurface system there are number of fractures developed. And now the question arises, if the system is in the subsurface, how the surface system will respond to this system? There is no response in a particular time scale, but with time, if these fractures will be there, there will be subsidence occur here through these fractures, then the geomorphic processes which are working on the surface, they will respond. So, those subsurface features, either it is shallow subsurface or deep subsurface, they may or may not affect this geomorphic process in the surface in a particular time window, but the same deformation, same amount of deformation with geological future, they may also affect the superficial process. So, that affect this process and this effect, it may not immediately or may immediately. So, depends upon the magnitude. If this process, if the subsidence occur very close to this faulting activity, then the superficial process will active together. So, if it is taking time, some hundreds of year, even tens of year, even if a year, then this surface geomorphic process will act or react accordingly. So, development of these faults is either due to the recent earthquake or any previous earthquake is not clear here, but either this fault will be affect the surface geomorphic process or not, that depends upon how this how the subsurface processes or how the subsurface structures that will grow and will reach near to the surface, because superficial geomorphology is a superficial process. So, anything close to surface or anything on the surface, that will affect the geomorphic process, is not it. So, that depends upon whether this subsurface process to what extent they are influencing to the system. So, the strength of this Holocene is there, and there are some merits and demerits of this system. So, strength of Holocene to study the geomorphic process is there. The record is often most complete. In Holocene, the record is most complete, because we know these processes which are going on in front of us, and dating is most precise, because as we have discussed earlier, in Precambrian rocks, once we are dating, it is suppose for example 570 million years plus minus 10 million years. So, 10 million years is the error, but the geomorphic processes, they are of these quaternaries, they are within some thousands of years, some hundreds of years scale. So, in that error, if we are putting this geomorphic process it will be of that is our foolishness. So, that means geomorphic, that is why dating is most precise in quaternaries in Holocenes, and that is why the once dating is precise, that means the rate, at what rate it is working, at river is eroding, at what rate eroding, deposition is going on, at what rate is eroding. So, that rate calculation of the rate is very precise. Then rates may completing process, rates of many competing processes can be directly evaluated or it is measured. So, there are climatic change, there are deposition, there are erosion, within that erosion there is fluvial erosion, aeolian erosion, glacial erosion. So, different contributing factors can be readily identified and different measurement for individual process can be calculated separately. So, their interactions can be examined, whether one is influencing the 2 or 3 is influencing 4. So, different processes, that means different individual processes, either they are interacting with each other or not, that can be calculated here. So, this is the strength of this Holocene, and its some disadvantages also. The rate of tectonic processes may be sufficiently slow, or the occurrence of deformational events such as earthquakes may be sufficiently rare than the tectonic signals to be obscured. So, here this tectonic process, the rate of tectonic activity, the rate of tectonic process may be it is a slow process as compared to this geomorphic process, the act of geomorphic process. So, that means suppose one fault is a recurring event or the recurring occurrence frequency is about thousands of years. So, within that thousands of year the geomorphic process will modify the system. So, that means we cannot know that whether this tectonic is influencing the geomorphology or not. So, the rates of geomorphic processes during Holocene or the interglacial time may not be very representative of this long time scale. So, whatever the geomorphic processes nowadays we are calculating within the interglacial period 10,000 or 11,000 or 12,000 years back. So, it may not be represented with the whole time scale. So, that means the rate of geomorphic process which is nowadays going on may not they are working at the same rate in the geological past. So, the time it takes for the geomorphic system to respond to a change imposed by the tectonic forces can be longer than the Holocene. So, here it is important, the Holocene is starting about 11 or 12,000 years back. So, that time scale is maybe not sufficient to this geomorphic system to respond for a particular tectonic event. So, thus the geomorphic system may be in a state of transition with respect to tectonic contribution imposed on it. So, these are some advantages are there, some disadvantages is there. So, this is all about this tectonic geomorphology, and it can be summarized here. This tectonic geomorphology is nothing, it is the influence of tectonics on geomorphology and how the tectonic process is influencing the geomorphic process and how the geomorphic process is modifying the tectonic features together. And the rate is important, the dating is important, the precise dating nowadays is available. So, that the rate can be identified precisely, calculated precisely, so that we can predict through a geomorphical model how this geological future, in geological future this type of tectonic activity is going on, what will be the landscape position, what will be the landscape modification, and where will be the habitable area, not habitable area, where this river will be flooded, which river basin will be encroached by the sea, which will above this sea level, like that. So, this is all about this tectonic geomorphology. I think we should stop here. Thank you very much.